Hello all, in this class we'll discuss about simple harmonic motion. So cam that produces simple harmonic motion on the follower are called eccentric cam. So eccentric cams we are using that eccentric cam does not intersect that center of circle. Okay, so basically how to plot that simple harmonic motion. So to draw that simple harmonic motion, okay, in simple harmonic motion the what we can say the wear and tear is very less, okay, and motion is very smooth. So basically to plot that simple harmonic motion, again we have to plot theta zero angle of rise, dual and return, and we have to divide that particular part into 6 or 8 equal divisions. Okay, based on that we can create a circle. Okay, and we can achieve that particular orientation of that particular uh, theta, that is cam rotation. Just I will brief you about the displacement diagram for that simple harmonic motion. Just look at the statement. So what we have cam with radius of 25 mm that rotates in clockwise direction. Okay, and it is rotating in clockwise direction with uniform speed. Now what we have here, the it is lift of that follower is given, it is raised to wall through 50 mm, that is lift of follower is given 50 mm in 120-degree rotation. To keep the wall fully raised, that is, the displacement of wall will remain same, that is constant in next 30-degree rotation. And to lower the wall during next 60-degree rotation, that is return is given. And to keep the wall closed during the rest of the rotation means the we have uh, next part 150-degree, that is given wall closed. Okay, and the diameter of roller is given 20 mm, the diameter of camshaft is given 25 mm, and we have to draw the cam profile when the line of stroke of wall pass through the axis of camshaft and line of stroke of the wall offset by 50 mm. Okay, and we have the displacement of wall being raised and lowered to take place these combinations with the help of simple harmonic motion. Also, we have to determine the maximum acceleration of wall. Okay, when the cam speed is 100 rpm. So we can plot this arrangement of cam and follower contour with the help of this displacement. Now look at the first part. What we have, the orientation is given. The lift of follower is 50 mm. So on vertical axis, y-axis, we can draw 50 mm line that is representing lift of follower. On x-axis, we have 120-degree angle of rise, 30-degree angle of dwell. We have 60-degree angle of return, and 150 it is remaining angle, that is angle of dwell. So we can draw one semicircle with that diameter of 50 mm. So radius will be 25 mm. Now again we can divide that semicircle into 6 equal division. Each division will be of 30-degree, 30-degree, 30-degree. So we have this point 1, 2, 3, 4, 5, 6. Okay. Now again we can assume some scale. So for 120-degree we can take scale 1 centimeter is equal to 20 degree. Just again I am writing this part. So to plot this displacement diagram, I can assume scale 1 centimeter is equal to 20 degree. That is my scale to plot displacement diagram. So this line will be of 6 centimeter. This line will be of 1.5 centimeter. And this line will be 3 centimeter. Okay. Now you know to 6 centimeter we can divide into 6 equal parts. So each part will be of 1 centimeter, 1 centimeter. This 1.5 will remain same. Again divide this 3 centimeter into 6 equal parts. So each part will be of 0.5 centimeter, 0.5 centimeter, 0.5 centimeter. Okay. Now just connect first inclined line with first vertical line. You will get first point. Connect second inclined line with second vertical line. You will get second point. Third inclined line with third vertical line. You will get third point. Fourth inclined line with fourth vertical line. You will get fourth point. Fifth vertical line and fifth inclined line, you will get fifth point, and sixth vertical line with sixth point, that will get 6 points. So these are the divisions of all these points. So simply connect all these points with freehand curves. We'll get point smooth curve of simple harmonic motion. We have point A, B, C, D, E, F, G, H. Okay. Then again I, J, K, L, and P. Okay. So these are the points. So you can create mirror image towards right side. So this is the reference line. So first left, first right, second left, second right, third left point, third right point, fourth left, fourth right, fifth left, fifth right, and the closing point. Okay, so simply in this way, you can create this. You can create this arrangement of simple harmonic motion, displacement diagram with simple harmonic motion. Okay. Now next, after plotting the displacement diagram, you have to again draw the roller circle. So what data we have? Roller dimensions are available. What is the roller part? So minimum radius is 25 mm. Okay, that is the value, and we have diameter of roller 20 mm. Okay, so we can draw two circles. One is of 25 mm Okay, one circle is of 25 mm. Again, I can show you this part. So first draw this circle of 25 mm. Okay, and second circle with a diameter of 25 plus 20, that is 45 mm. Okay, so just draw this circle. This circle is having radius 20 mm, and we have second circle. Okay, having diameter is 25. Okay, so radius will be 12.5. Okay, so second circle will be having dimensions 32.5. So these two circles we need to plot. Okay, second circle having radius of 32.5. Okay, after creating these two circles, okay, we have to mark the angles. 120-degree angle, angle of rise, that is first angle. This angle is theta 0. I can show you. Then next angle as it is theta d, and third angle is theta r, angle of return 60 degree. Okay, so 120 plus 30 plus 60, that is 210. Remaining is 150 degree. Okay, that value we need to plot. Now again, just locate the distances. Displacement value 1b, 2c, 3d, then 4e, 5e, 6f, 6g, 0-7h, then I, j, k, l, m, and p, and draw ruler at each and every location. So just we have to draw ruler at each and every location and connect the base points of all these rulers. So base point will represent cam control. So in this way, we can draw cam control, okay, for this inline ruler follower. Okay, so first case was given inline ruler follower. Now we have second case. Okay, in second case, we need to draw offset ruler follower. So basically in inline ruler follower, we are only creating we are only marking these points on that line 1, 2, 3. That is displacement points we are marking. Lift of that wall 1b, 2c, 3d, 4e, 5f, 6g. Then we have 0 dash 1 dash j, 2 dash k, 3 dash k, 4 dash m, 5 dash n, and 6 dash. On all these points, we have to locate the all the point and draw the ruler at each and every location, and you will get the contour. Now second case we have. Okay, so in second case, basically again we need to draw offset follower. So for offset, what data we have? Offset distance is available. Now look at the distance. What is the offset distance? Offset distance is given 15 mm. Okay, now again we need to create this circle of 15 mm. Okay, then we have second circle, this circle of 25 mm, and we have third circle, that is roller circle. This circle is, that is 25 plus 12.5, 37.5. These three circles we need to draw. After drawing this, we need to take O. Suppose the center of cam is O. OA will be the reference line. Okay, with respect to this reference line, OA reference line, we need to mark the angles. So how many angles we have? Again, we have 120-degree angle, angle of rise. Then we have 30-degree angle, angle of dwell, and we have angle of return 60 degree. So again, divide that 120 degree into 6 equal parts, 30 degree as it is, 60 degree into 6 equal parts, and draw tangential line. Okay, tangential to this offset circle. So you can draw tangential line for 0.1, for 0.2, 3, 0.4, 0.5, 0.6. Again, as it is, 6 dash and 0 dash, then 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash will remain as it is. Now for above 1A, we have this 1B distance. Just mark the distance 1B. Then we have 2C distance, then we have 3D distance, 4E, then we have 4E distance, 5F distance, 6G distance. Okay, and by locating all these points, again we need to take the ruler. Okay, so 12.5 mm is the radius, diameter is 25, they have given. Okay, so just look at the part. Okay, and draw the rollers at all these locations. Okay, and simply we need to connect the base points. So after connecting the base points, we will get the cam contour. So in this way, we can draw cam contour for this offset roller follower. Okay, so we have these two types of motion, roller follower motion. One is inline roller follower, where we can directly draw that part. Okay, okay, just look at the arrangement. In case of inline, just I will show you how to draw inline and how to draw offset. Okay, so in previous case, we are directly plotting we are marking the points. Okay, 1B, 2C, 3D, all, and simply by creating circles at all locations, we are getting the curve. Whereas in second locations, what we have offset distance is given, and on offset distance, we are locating that reference line, and with respect to that orientation of A and O, we are marking the angles 120, 30, 60. We are drawing tangential lines, and above that, above roller circle, we need to look at the displacement values 1B, 2C, 3D, 4D, and draw the circles at all these locations of A, B, C, D, E, F, and simply by connecting base points of all these circles, you will get the cam contour. So remember that starting point will touch to the radius of base circle of cam, and final point of the final roller follower will also touch to the base point of the cam, and then your contour will get close. So in this way, we can draw roller follower, inline and offset roller follower with simple harmonic motion. Okay, so thank you all.